Let's go to E-Deli.
Okay. Oh no, the car won't start.
Do you think the battery's dead?
Seems like it.
Well, I saw an episode of Breaking Bad where Walter White jump-started a dead RV with a makeshift battery that he created from scratch.
You mean like this?
Hahaha, no. He made a mercury zinc galvanic cell.
One cell of the battery. Here, cut up the last 2 sponges. Remember the electrolytes? Huh? Well, think about it. A battery is a galvanic cell. It's no more than an anode and a cathode separated by an electrolyte, right? Right. Yeah, well, anyway, here. On one side, you have mercuric oxide and graphite from your brake pads. This is the cathode, this is the positive terminal. This is where the supply of current flows out from, you see? And, here, I'll show you. On the opposite side is our anode. This. It's zinc. It's what we find in our coins and anything galvanized.
So the sponge is the electrolyte?
Yeah, well, no, the potassium hydroxide is the electrolyte. But yes, that's what I'm soaking the sponges in. Good. Good, and now, what shall we use to conduct this beautiful current with? What one particular element comes to mind?
Wire.
Copper.
Oh, man.
Copper. The only question now is, will this supply enough current? And how many cells will we need? We've only got material enough for 6. Okay. Put the lid on. Wait. Positive. Right. Cathode. Anode.
Oh, hey, didn't see you there. I'm Julian Green, your host for Crashing Crash Course. In today's episode of Crashing Crash Course, I'll be teaching you how to make a battery. Don't forget your goggles. Because Walter was a smart guy, he created his own battery using 2 half reactions. This formed 2 cells, an oxidation cell and a reduction cell. In order to understand how a battery is made, let's go to our thought bubble.
In order to create a battery, Walter created 2 half cells, a cathode and an anode. In the cathode, it undergoes reduction, remember red cat, while an anode undergoes oxidation, remember NOx. To create his cathode, Walter used mercury oxide from his braking pads. Remember, mercury's oxide is an insulator, therefore you need graphite. Also, because mercury is a liquid, the presence of the fairly inert powder, graphite, will help it stop cooling. In an anode, he used zinc, coins, washers, nuts, and bolts, and other galvanized materials. Walter used all the materials he could find in the RV and ended up creating 6 cells. The real question is whether or not they were strong enough to power his RV.
Now that we got the basics covered, let's answer the real question. Will this battery be able to power the RV?
So in the anode part of the cell, we have oxidation of zinc. And according to the standard reduction table, this is negative 0.76 volts. But since this is the oxidation, we have to negate this, making this positive 0.76 volts. Now for the reduction in the cathode. Mercury oxide is being reduced to yield a reduction potential of 0.85 volts.
In order to find the standard potential for the entire cell, you must add the values of the cathode and anode together. one cell is 1.61 volts. However, since Walter combined 6 cells, we must multiply this number by 6, and you get the final overall cell potential is 9.66 volts.
The Nernst equation allows us to calculate the cell potentials of a cell that is not in standard conditions. In a desert, the temperature is a lot higher than 25 degrees Celsius, and as such, using the Nernst equation, we can calculate that the potential of the cell is going to be less. As such, the calculated 9.66 volts of the 6 cells combined will ultimately be decreased using the Nernst equation. If an RV needs 12 volts to jumpstart its engine, and we only have 9.66 volts or less, we can safely assume that Walter's battery is fiction.